Chapter 3, Exercise 21. Hints. Pick a point xn in En for each n equals 1, 2, 3, and so on. Prove that xn is a Cauchy sequence. Argue that the limit x equals limit n to infinity xn is the only limit point of this. Solution. Denote E equals this. Choose a point xn in En for each n equals 1, 2, 3, and so on. For any epsilon greater than 0, there exists an integer n such that diam En less than epsilon. Assume that n m greater than or equal to big N. Since this and that, we have this. In other words, xn is a Cauchy sequence. Denote x equals limit n to infinity of xn, theorem 311. Since En is closed and xm in En for all m greater than or equal to n, we deduce that x in En. Indeed, if x not in En, then there is a neighborhood here. However, for all large enough m, we have this. This is impossible, since if m greater than or equal to n, then we have the following. We have proved that x in En for all n equals 1, 2, 3, and so on. That is, the following. Since we have this, and limit n to infinity diam En equals 0, we have that diam E equals 0, and the set E consists of exactly one point x. Comments. Obtained result is similar to the corollary of theorem 236 for decreasing sequences of compact sets. The converse of the result of this exercise is also true. Let XD be a metric space in which every decreasing sequence En of closed bounded sets with limit n to infinity diam En equals 0 has a non-empty intersection. Then XD is complete. Indeed, let Xn be a Cauchy sequence in X. Denote En equaling this. Sets En are closed, non-empty, and decreasing. For any epsilon greater than 0, there exists an integer n such that this. It follows that diam En less than or equal to epsilon, see theorem 310a. In other words, limit n to infinity diam En equals 0. By assumption, there exists a unique point x in this. For any epsilon greater than 0, there exists an integer n such that diam En less than epsilon. If n greater than or equal to big N, then xn x in En, and we have the following. The sequence xn is convergent. Another remark is that the condition limit n to infinity diam En equals 0 is important. For example, consider the set J of all positive integers with the discrete distance here. Exercise 210. A metric space J is complete as every Cauchy sequence Nk in J stabilizes. There exists K0 such that this. All sets in J are closed and bounded. Let En equals this for n equals 1, 2, 3, and so on. Note that this. Thanks for watching.